Alright guys, section 4, logarithms. That's the one you guys may have trouble with, but I hope not. I'll try to break it down for you best I can. So, what is a logarithm? That's kind of hard to explain, but in basic terms, I found out some basics here. In its simplest form, here's what it is. In its simplest form, the logarithm answers the question, how many of one number do we multiply to get another number? Meaning this, how many 2's do we multiply to get 8? And you would know, 3 2's, right? So the logarithm is 3. That's what it is in basic, okay? So when we do something, I could set something up like this. How about if I wrote it like this? 3 to the blank, or maybe I'll put an x here, is equal to, we'll say 9. Okay? Same idea. What is x? 3 to the power of 2. So you would say x equals 2. So this is exponential form right here. Logarithmic form, you're doing the same thing. We would say log base 3, that's a base up here, of 9 equals something, equals x. Okay, so there's two forms you have to know. Alright, you have to know this form, and this is actually the same thing as this. Okay, what we're trying to do is we're trying to find the exponent. That's what you're trying to find up here, right? You're trying to find the exponent that made this true. That's what you're finding down here. Okay, a logarithm is an exponent. Okay, that's what you're finding. So log with the base of 3 of 9 is what? So here's how you do that. You think of this as like this. You would say to yourself, okay, 3 to some power equals whatever's sitting here, 9. Oh, you'd say, okay, that's 2. Alright? This is how you figure out. Anytime you see in logarithmic form, you want to kind of change it back to exponential form. Okay, you'll get used to this as time goes on. Alright, so let's do another one. Okay, if I said the log base 2 of, let's go with 16. Okay, what is this equal to? All you have to do is think these things. You take the base. Here's this little number is a subscript, which is your base. So 2 to some power, you don't know, so we'll put x is equal to whatever's sitting right here, 16. You see the process? It doesn't matter if you know exactly what a logarithm is. All I want you to see is a pattern right now. Okay? If you see a log function, you just say, okay, 2 to some power is equal to 16. And you should know what that is. X is equal to, x is 4. So 2 to the 4th equals 16. So this is your answer. You just found a logarithm. Okay? So you would say log base 2 of 16 is equal to 4. Alright? It's not too bad. Alright? Now, so let's log base b of y is equal to x. Write this down. This is the general equation. Okay, all letters here. This is logarithmic form. So if it looks like this, it's a logarithm. If you see log, obviously it's a logarithm. So this is in logarithmic form. You can always change logarithmic form into something else that you're probably more comfortable with. You can always change it to b, the base, okay, to the power of what power? Well, whatever's on the other side is the power. A log is a power. So this thing right here is a power. So you put that power right there. Whatever's sitting here, you put it as a power, is equal to whatever's sitting right here, which is y. Okay? These two mean the same thing. They're just different forms. The second one is exponential form, which that's what, section 1, exponential form. So kind of be able to switch back and forth. If you see this, you should be able to say, okay, log base b of, so that's what you should be able to do. If I give you something like this, you should say, okay, that's the same as log base, whatever's sitting here, which is b, of y is equal to the exponent. The log is equal to the exponent, which is, in this case, x. Okay? Be able to go back and forth. This is how you're going to be able to solve your log problems. So let's do some examples. Okay? Let's go back to the, so make sure you write this down. This is important. Let's go back to the slides, go through some problems. Section 4, logarithms. Alright, so all they want you to do is, example 1, rewrite the logarithm. So if you have log base 2 of 8 equals 3, alright, then all you have to do, is take the base, put it here, of the exponent. Remember, the exponent is on the other side, equal sign. Log is an exponent. So here's your exponent right here. So 2 to the third equals whatever's sitting here, 8. And that makes sense, right? Log base 2 of 8 equals 3 is the same thing as saying 2 to the third equals 8. Alright, simple enough. Next one, log base 4 of 1 equals 0. Alright, so 4 is the base to the power of what? What's the power? Over here. 4 to the 0 equals whatever's sitting here. Doesn't that make sense? Equals 1. 4 to the, anything to the 0 equals 1. True. Makes sense. Next one. Log base 12 of 12 equals 1. So 12 base to the exponent, 12 to the first equals 12. Just be able to convert back and forth, back and forth. Alright, last one. You're going to get fractions, you're going to get negatives, you're going to get a bunch of stuff. As long as you know the process, it's fairly easy. So you do 1/4 to the power of -1. Makes sense that that would be equal to 4. So 1/4 to the -1 power equals 4. You flip it and there it is. Okay, that's how you change logarithmic to exponential form. There's some guy to practice. You know, I think you're okay with that if you understood the first part. Example 2, you're going to evaluate the logarithm. You're going to find out what the logarithm is equal to. So, question number 1, log base 4 of, that's how you say it. So, make sure you know how to say this. Log, in words, if you were talking to me, you'd say log base 4, there's that little 4 is the base, of whatever number is right here, 64. And then you'll say equals something. You figure it out. Log base 4 of 64 equals, how are you going to do this? We set it up. Change it back to exponential form. So you'd say, okay, how do you figure this out? 4 is the base to the power of, what's the power? You don't know. That's what you're trying to figure out. A logarithm is a power. You're trying to figure out what the power is. 4 to the, we'll say x. You don't know. Equals, whatever's beside the 4, 64. 4 to what power is 64? You all should know this. X should be equal to 4 to the, so x is 3. There you go. So log base 4 of 64 is equal to 3. Alright? You see how this pattern works out? Even if you don't understand exactly what a logarithm is, how it works, you should know how it works. Okay? That's what you should know. What's the pattern here? Figure it out. Once you figure it out, this stuff can be fairly easy. So it says, in the book it'll tell you how do you find the value of log base b to the y. Ask yourself what power of b gives you y, right? What power of 4 gives you 64? Maybe that's easier for you to understand. 4 to what power gives you 64? You would say 3, right? That's why the answer's 3. Look at this one here. This is a little bit better. It's a decimal. So how would you do this one? Let's do it like up above. 5 to what power gives you 0.2. You gotta ask yourself, what is 0.2? 2/10, right? 0.2 is 2/10. What is 2/10? Really, that's 1/5, right? So basically it's saying this: 5 to what power is 1/5? So I would write that out. 5 to what power equals 1/5? Can you look at that and tell me? 5 to the -1, right? So x has to be -1. So the log base 5 of 0.2 is -1. There you go. So now you can evaluate a logarithm. 5 to what power gives 0.2? That is -1 is your answer. Okay. Alright. 1/5 to, okay, this is letter C of example 2. 1/5 to what power is 125? So that's what I would write. 1/5 to some power equals 125. So, well, 1/5 to any power is going to give you a fraction, except if that power was negative, right? If it's negative, then it's going to flip 1/5 to 5. So, I know x is negative, okay? Okay, what is 125 the same? Here's what I do sometimes. What is 125 the same as? 5 to the third, right? So 1/5 to the power of x equals 5 to the third. Alright, this is a different way to think about it. I don't think the book goes this route. How can I change 1/5? I like to get them both to the same base. That's what I like to do. Okay? 1/5, or you can think, I can go this way too. Instead of 5, how can I change 5? 5 is the same as 1/5 to the -1, right? 5 is 1/5 to the -1. You understand that? So these two are the same, only I still need this 3. So I'm going to put this all to the third. Everybody see what I did there? Or did that confuse you? Just look at it again. I just said 5 is the same as 1/5 to the -1, which is true, alright? To the third power. So these two things are the same thing. So 1/5 to the power of x is equal to, let's say 1/5 to the 3 times -1 is -3. Now do you see what we can do here? 1/5 to the x is equal to 1/5 to the -3. X has to be -3. There you go. So answer equals -3. Okay? So that's another way you can do it. Remember this kind of method I use. I like to get them both to the same base. 1/5, 125. Oh, I know I got a 5 in there. So change it both to 1/5. Or you could have changed this one to 5 instead of going 1/5 route. That's what I was about to do. 1/5 is the same as 5 to the -1. So this side would be 5 to the... That might be easier. Let's look at that real quick. I'm going to change 1/5 to 5 to the -1. Right? To the power of x. So we got this equals 125 is 5 cubed. So look at that. 5 to the -x equals 5 cubed. All you have to do is say, well, look at that, they're the same base. So all I have to do is say, okay, -x has to equal 3, which means x equals -3. Same answer, different route. Alright, just remember that. See what the book does here. Let's see. So it says, ask yourself what power of b gives you y, and 1/5 to what power gives you 125. So I mean, they just assumed you would know that, which is fine. You should, but I worked it out by hand. Letter D, log base 36 of 6. Okay. This is a decent one too. So what does this really mean? In exponential form, 36 to the power of something gives you 6. So, you guys think about that? 36 to some power is 6. You guys remember what? The last chapter? What if that power could be a fraction, right? 36 to what power gives you 6? 1/2. Right? 36 to the 1/2 means root 36. Root 36 is 6. So 36 to the 1/2 power, which is square root of 36, equals 6. So really this answer is 1/2. What if you couldn't think that way? Okay, do it like I did this last problem up here. Okay, let's kind of make a thing here. 36 to the x equals 6. I like to make them both the same base. So it's 36 and 6. Let's make them both 6. Well, this one stays the same. 36 is the same as 6 squared to the power of x. So 6 to the 2x equals 6 to the first, right? That's what I just did here. 6 is 2x equals 6 to the first. Look, they're both the same base, which means 2x has to equal 1, right? So I write that down. 2x has to equal 1, which means divide by 2, x equals 1/2. So I did it algebraically instead of doing it all in my head. Some people might not see that. 36 to 1/2 equals 6. Okay? There you go. You know how to evaluate logarithms so far, and you know how to just change the forms. Those are big ideas.